Welcome back. This is the third lesson recording for IM2, April 15th, 2021. So we've just looked at what happens to the perimeter when the polygons get enlarged. So here, the side length dimension went from 4 to 12 and 6 to 18. So the scale factor was 3. Now, we just figured out that with perimeter also tripled when the dimension, each of the dimensions were tripled. So that makes sense because we're talking about a linear expansion here. So here we're measuring a length and perimeter was also measuring the length. So it makes sense, it just triples. Now this time we're going to consider area. Okay, to figure that out, what is the area of the original picture? 4 times 6, the area is going to be 4 times 6, which is 24. Okay, what about this area? After enlargement, it's going to be 12 times 18, which is going to be, when you use the calculator, let me use that really quickly, 12 times 18 is going to give me 216. So we found that perimeter is just tripled when we enlarge the side length by scale factor of 3. Did the area also just triple? 3 times 24 is going to be 72, not 216. So what happened? What happened to the area? Well, we know that when the side length was 3 times bigger, the perimeter, this is the linear scale factor. What happened to the area? Area went from 24 to 216. And so if I do 216 divided by 24, that is going to be 9. That means the area got multiplied by 9. Okay, so we know that when scale factor is 3, the area scale factor is 3 times 3 or 9 times bigger. Okay, so just the same way, area, that is because you've tripled the one length as well as you tripled the other length. So it's not just multiplying the original area by 3, but you need to multiply the original area by 3, whatever the scale factor being squared. So 3 times 3 is 9. So that's being multiplied by 9. So this time you're going to do a quick exercise. Here you have a sample size of, so what's happening is you are creating a banner for your school team, and you have a sample size that has the dimension of 1 foot long, and then the actual size that you want it to be 3 feet long. So what happened to the area? So to do this, you are going to make a copy of this slide. And when you make a copy, it's going to look like this. So from the slide link that I'm going to be sharing in the class, it's going to ask you, do you want to make a copy? And you're going to say yes. And this is going to be your own copy, and you're going to explore that yourself. You are going to share this with me, so please do that activity. The first card says, how many times bigger is the area? Use as many of the sample to fill the actual flag. So here are the sample size, and you're going to move those, okay, one by one. Okay, so there is one move there, and we need to fill it up, okay? So then I can bring that to here to fill it up. And I know I need one that's pointing up, and so on. So you're going to keep filling it up with these Okay, so and you should have found that how many of the samples can you fit into the original or the actual. You should have been able to fit in 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Okay, the scale factor was 3, but the area increased by 9. That's because we needed to multiply 3 times 3, not just 3. Okay, what about perimeter? Let's explore perimeter. Well, this is the length, so we can move each one of the lengths. That's 1 red, the original length, and that's 2, and that's 3. That fits. Okay, and what about at the top to move that? Okay, and I can fit in another, and another. Okay, so 3 of them fits, and for the side, 1, 2, and 3. So you can tell that originally each of the side length, that was one of each color was the original perimeter, but then the perimeter tripled. So this is a visual representation of that. Going back to our slides. Okay, now we're going to extend that to other shapes other than rectangles or triangles. What about this hexagon, 6-sided polygon hexagon? In this case, the side length went from 10 to 30, even though it does not look like it. If it has the measurement of that, then you believe that it is. So it tripled, the side length tripled. What do you expect? How do you expect the perimeter to have changed? Well, the original perimeter was 10 plus 10 plus 10 plus 10 plus 10. So the original perimeter was 60. Okay, what do you think the perimeter will be? The scale factor, linear scale factor is 3. So you multiply by 3 to go from the original to the new. So perimeter is also going to triple as well. So 60 times 3 is going to be 180. And we know that that is true because if I know that this is 30, this is going to be 30, 30, 30, 30, 30. So it is going to be 30 times 6, which is 180 as well. Okay, what about the area? Okay, how many times bigger is the area? Now, it's not asking me what is the area. Okay, so you don't have to calculate it, the area, but you just need to calculate how much bigger, how many times bigger is the perimeter, and it is going to be bigger by not just 3. The area is going to be bigger by 3 squared, so it's going to be 9 times bigger, while its perimeter was 3 times bigger. And this is 9 times bigger. So now you're taking some notes on area and perimeter of similar figures. So when you have any 2D dimension figure is enlarged or reduced by a linear scale factor of r, all length or the sides, perimeter, and height of the enlarged or reduced figure are also multiplied by r. But the area of the enlargement or reduction is multiplied by r squared. So for example, if you have this triangle that went from 6 to 9, what is that was the original and that is after the enlargement? The scale factor, linear scale factor is the enlargement. What number am I multiplying to get from 6 to 9? It's 9 divided by 6, which is 1.5. So you're multiplying by 1.5. That means the perimeter is going to be multiplied by 1.5. However, the area is going to be multiplied by not 1.5, but it's going to be multiplied by 1.5 squared, which is 2.25. So now you're going to be working on Desmos activity. So this is the last Desmos activity. Here we are asked to enlarge the figure so that the scale factor is 2.5. So I have this figure drawn here. I need to enlarge it. That means I need each of the length to be 2.5 times its original length. Okay, so then what do we have here? We have the length of 3 and 2, so that's 5 right here. So I know that this length is 5. That means multiply 5 by 2.5 is going to be 10.25. Okay, or 12.5. So doubling that is 10, and then multiplying that by 2.5 is going to be 12.5. So I want this length, the vertical length, to be 12.5. So I need to count. I need to go from here all the way. That's 5, 7, 9, 10, 11, 12, and 15. 12 and a half is right there. So I need, let me redo that. So I need to go from here all the way to 12.5. I believe is right here. Okay, now I need to go to the right by it's two units here. Oops, 2 units here. So then double that. 2.5 times that is going to be 5. So I need to go across by 5. So I'm going to get my line tool, and I am going to go from here to 4 and 5 right here. Let me redo that. Okay, then I need to go up. Let's see. So I need to, so from here, I need to go up by 2. 2 times 2.5 is going to be 5. So I need to go up by 5 units. So I need to go from here to 1, 2, 3, 4, 5. And then I need to go across by 2. 2 times 2.5 is going to be 5. So I need to go here. And then from here, I need to go all the way back to my original. That should be my enlarged by the factor of 2.5. Now, what is the perimeter of the original shape on the left? I have 5 here. 5 plus 2 is going to be 9. 9 plus 2 is 11. What is this length, the diagonal? How do I figure that out? To do that, I need to use Pythagorean theorem. The length here is going to be 4. And this length is 3. For this triangle is 3. 3 and 4. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. So I know that this length was 5. So I have 3 and 2. That's 5, 7, 9, 11 plus 5 is 16. So I have 16 units as my perimeter. What is the new perimeter? I am just going to give you the answers. And here are my answers.